One of the difficulties encountered by elementary students is the memorization of multiplication table. Some students took some days, weeks, and even months before they could master it. Here is a way that may shorten the process. First, let us start with the easiest, that is multiplying by 1. Just remember that any number multiplied by 1 is equal to the same number. So, these are the numbers that we multiplied with 1, and the result we get is the same number. 1 times 1 equals 1. 1 multiplied by 2 is equal to the same number, which is 2. 1 multiplied by 3 is equal to the same number, and that is 3. And that goes for the rest. So we are done with multiplying by 1. Let's go now to multiplying by 10. In multiplying by 10, just remember this. Just put 0 after the multiplier. Again, the red colored numbers are our multiplier. And to get the answer, we will put 0 after the multiplier. And that's how easy to get the answer in multiplying by 10. Multiplying by 9, the first step is to change 9 with 10. Because multiplying by 10 is easier than multiplying by 9. So 9 times 1 becomes 10 times 1. 9 times 2 becomes 10 times 2. And so goes with the rest. After getting the product, we will deduct the multipliers from it to get the answer for multiplying by 9. Now we can check our answer by adding the digits of the product, and we should get 9 as an answer. Let's move on to multiplying by 5. Remember this, 5 is equal to 1/2 of 10. Hence, 5 multiplied by any number is also equal to 10 multiplied by the same number divided by 2. If you have difficulty multiplying by 5 at first, change 5 into 10 and then proceed with multiplying by 10, which we have already discussed in the previous lesson. 5 times 1 becomes 10 times 1. After getting the product, divided by 2 to get 5, which is the answer for 5 times 1. So, the product we get from multiplying by 10, we just divide it by 2 to get the answer for multiplying by 5. Moving on, let us go to multiplying by 8. If you will notice, there are missing combinations here. They were purposely deleted because those combinations are already covered using the commutative property of multiplication, wherein A times B equals B times A. Remember, we have already covered 1 times 8, 5 times 8, 9 times 8, 10 times 8. So there is no need for us to study these combinations. So we will focus our efforts in these combinations. So, we have here 8 times 2. Remember, any number multiplied by 2, you just double that number. So, 8 plus 8 equals 16. 8 times 3, the answer would be those numbers wherein 3 is in the middle. So, if we count 2, 3, and 4, the number 3 is in the middle of it, so that will remind us of the answer, which is 24. 8 times 4 equals 32. Before 4 are numbers 3 and 2, so we can create a pattern, a declining pattern of 4, 3, 2. Again, 4 will remind us of our multiplicand, and the answer 3 and 2 will remind us of the answer 32. 8 times 6 equals 48. Remember, 8 times 5 equals 40. So 8 times 6, you just add 8 to 40. So 40 plus 8 equals 48. 8 times 7 equals 56. To remind us of the answer, let us create a pattern for it. We reverse 87 and make it 87 and place 56 in front of it or before it. So what we will have is 5, 6, 7, 8. That pattern will remind us of the answer 56 for combination 7 times 8 or 8 times 7. 8 times 8 equals 64. Whenever you encounter this combination, remember the chessboard which has 8 equal parts on each side and has 64 playing squares. So 8 times 8, just remember the features of a chessboard. Combinations covered using the commutative property of multiplication will be excluded in the succeeding presentation. So when we go to 7, 6, 4, 3, and 2, we will already exclude those combinations which we have already covered by using the commutative property of multiplication. Just like here, wherein we no longer discuss these combinations because they are already covered in the previous lessons. It helps also that we study the pattern that we can get from the products in multiplying by 8. Take a look at the rightmost portion of the answer. And we can create a pattern here that it starts with 8 and then it declines by 2 until it reaches 0. And then for 8 times 6 up to 8 times 10, it starts with 8, declines by 2 for every combination until it becomes 0. Let us go to multiplying by 7. There are 5 combinations left here because the other 5 are already covered by using the commutative property of multiplication. 7 times 3 equals 14. Remember to double the number 3. Add the number by itself. So we add 7 by itself equals 14. 7 times 3 equals 21. There is a clear pattern created here which is 3, 2, 1. So that will make us remember 7 times 3 and its answer which is 21. 7 times 4 equals 28. We knew that 7 times 3 equals 21. We just add 7 to it to get 28. 7 times 6 equals 42. We break down 7 times 6 into 7 times 3 plus 7 times 3, which will equal to 21 plus 21. That will lead us to 42. 7 times 7 equals 49. When in doubt, if the answer is 48 or 49, go for the odd number because 7 is also an odd number. We are now multiplying by 6. 6 times 8 was purposely included to complete the pattern for even numbers in multiplying by 6. Because when multiplying 6 with even number, the last digit of the answer will be the same as the multiplier. So, take a look at this. 6 times 2 equals 12. 2 and 2. 6 times 4 equals 24. 4 and 4. 6 times 6 equals 36. 6 and 6. 6 times 8 equals 48. 8 and 8. So there is a clear pattern when multiplying by given number. The multiplier will be the same as the last digit of the product. Six times 3 equals 18. We just add 6 to 12. Multiplying by 4. There are 3 combinations left, and one of it is 4 times 2. Again, double the number 3 multiplying by 2, or we add the number by itself, and in this case it is 8 plus 8, which is 16. 4 times 3 equals 12. Reverse 43, 4, 3, reverse it to make a pattern of 1, 2, 3, 4. So, 12 is the answer for 3 times 4 or 4 times 3. 4 times 4 equals 16. From the previous combination, we have 12. We just add 4 to it to get us to 16. In multiplying by 3 and 2, there is no need for further explanation because these are the easy ones. And we have eliminated almost all the combinations. That's all, and thank you for watching.